Good morning, students. Today we will discuss some important application question from COSHEM 2022, which was conducted recently. Okay, so the questions are very important questions, and you can use to check your answer. Okay, so let's take up question number 29 from organic chemistry, which is the first one. So question number 21, so let's read the question first. In a given reaction, identify the product A, write the UPEC name of A, and comment on the molecular chirality of A. Okay, 3 marks, organic. Okay, application type question. Okay, so let's try this question first. So I'll write the reactant question number 29. CH3. First it reacts with HCl, second reacts with aqueous KOH. Okay, so identify A. So our aim is to find A. Okay, so let's try this, students. This is alkene, HCl, so this electrophilic addition. So first let's do the steps. CH alkene, CH, CH3 plus HCl. So this pi bond will attack on this hydrogen. This bond will break to Cl. So when this when this pi bond attack to this hydrogen, the hydrogen may come here or here. Okay, clear? So let's write the two possibilities. In the first case, I'll let the hydrogen to come on this position. Okay, so I'll highlight with some different colors. So in the first case, the hydrogen is bonded in that carbon. Okay, this is red hydrogen, represented by the red hydrogen. So since the hydrogen is bonded here, there will be formation of carbon cation, okay, on this carbon. So in the same case, similarly here, suppose I fix the hydrogen in this case, then the carbon cation will be formed on the next carbon. Okay, so this is the two possibility. From this you have to select the correct one. Okay, so secondary carbon cation, this is also secondary, but the just next to this carbon cation there is benzene. So this is benzylic carbon cation, okay, which is more stable due to resonance. Okay, so this is benzylic, which is more stable. So I have to choose this, not this. Clear? So now what I will do is I will attack this chlorine on this carbon cation. So let's write the next step. Cl will come here, CH2, CH3. Next, it will again react with aqueous KOH. So right here, aqueous KOH. And we know that aqueous KOH we will undergo the nucleophilic substitution reaction, as chlorine is a leaving group. So this Cl will be replaced by OH, okay, by taking out KCl. So let's write the product here. CH OH plus CH2 CH3 plus KCl. Now this is A, and the question asks to write the UPEC name. So let's write here IUPAC name. First we'll do numbering 1, 2, 3. So 1 phenyl, this is phenyl. 1 phenyl, propane, 1 all. Okay, this is the EPIC name. And the next is chirality. Chirality. For chirality, we have to check the presence of chiral carbon. Okay, so let's check. Chirality. So students, this carbon number 1, you see one group is OH, the second group is phenyl, the third group is CH2, CH3, and the last group is H. Okay, so since all the 4 groups bonded are different, so this carbon is a chiral carbon. So the molecule A is chiral because chiral carbon is present at carbon number 1. At C1. Okay. So this is the steps required for question number 29. So students, you take a screenshot of the steps involved. After this, we'll take up the next question from organic chemistry. Okay. I shall wrap this now, students. Okay, so let's check the next one. Next one, we'll take up question number 31. Question number 31. Give the measure product and write the possible reaction mechanism for the reaction. Okay. Question number 31. This is also question carrying 3 marks. CH3, 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 CH, OH, CH3. Then it reacts with concentrated H2SO4, and we have to heat at 180 degrees Celsius. Okay. So let's try this together. We have to write the reaction mechanism along with the finding the measured product. Okay, so this is alcohol, and with concentrated sulfuric acid means this is dehydration reaction. We have started learning this even from class 10 also. Okay, so now we will write the reaction mechanism for this reaction. Mechanism. So let's start. CH3, CH, CH. So this is the dehydration. Your aim is to take out water and to form an alkene. Okay, double bonded hydrocarbon. Okay, so first step. In first step, this the lone pair oxygen will take away this hydrogen so that the bond is given to HSO4. So let's write the step here. CH3, 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 then CH, CH3, and here there will be formation of OH2 plus. Okay, OH2 plus HSO4 minus. This is the first step. Second step, here remove this part. Okay, just take out water. Okay, just take out this water so that there will be formation of a carbon cation, CH3, CH plus CH3. Okay, So now, after the removal of H2O, a carbon cation is formed, and here this is secondary carbon cation. So students, if you remove hydrogen, if you add, if you form alkene in these conditions, then you might fail to find out the major product, okay? Because we have studied that the stability of carbon cation follows the order tertiary, secondary, and primary. Suppose if there are any possibility that the secondary or primary can be changed to tertiary, then we have to do that change, okay? So for that, for the changing secondary to tertiary or primary to tertiary, there is two shift. There is hydride shift. The second one is methyl shift, okay? So just check whether there is any possibility of shifting this this hydride or the methyl, so that the carbon cation is becoming more stable, okay? So in this case, the CH3 can be shifted to here, okay? So this is CH3 shift, methyl shift. So the product will be here CH3, CH3, CH, this is the original H, this is the CH3, and I'll highlight with different colors here. This is the CH3 that comes from here, okay? This is this one, okay? So now the carbon cation is again formed in here, okay? So this is secondary and this is tertiary. So I think this is more stable. Okay, clear. Now this HSO4, this is the last step. This HSO4 will come here and take away this H, so that this bond is given to here. It will form a double bond, okay? So the product is CH3, CH3, then double bond will form here, CH3 and CH3, taking out HSO4 with H2SO4, okay? So in the equation they ask to find out the major product. Okay, so then this is alkene, and this is the most substituted alkene, okay? Because all the groups bonded to the double bonded carbon are methyl groups, okay? So which is the major product, which is given by Saytzeff rule, okay? Saytzeff rule. Suppose if you take the hydrogen from here, okay, then alkene will be formed here. So this will not be the major product, okay? If double bond is formed in this position without any change, without any shift, then this will be the minor product, okay? In that case, your marks will not be awarded, because it demands major product, means the alkene having the maximum number of CH3 groups, okay, or alkyl groups. So this is the major product, okay? So this is one of the very good important questions which was asked in that year, 2023, question number 31, okay? So students, the difficulty level of the council exam has been increasing in the recent years, okay? So you have to practice more application types questions in the coming exam, okay? So we will discuss the remaining questions in the next video. So don't forget to like and subscribe my videos, okay? So I hope the video might be useful to you in your studies or in checking your answers that you have done in the exam, okay? So students, for today we'll stop here and we will meet in the next videos. Okay then, bye students.